Okay, so last time, we talked about enantiomers. Okay, so enantiomers, two molecule, okay, mirror imaging to each other, but they are non-superimposable. Okay, so that's two different molecule. Okay, right, and then today we'll start with chiral. Okay, definition of chiral. Okay, definition of chiral is just one object or maybe one molecule. Okay, not superimposable to its mirror imaging. Okay, so then we call this molecule or this object is a chiral. Okay, most time people just show they show kind of handles. Okay, and one common example is just our hand. Okay, so our hand, our left hand and also right hand are mirror imaging to each other. Okay, and then but they not superimposable. Okay, so that means they are chiral. Okay. And another example is the left helix and also right helix. Okay, so they also the mirror imaging to each other, but non-superimposable. Okay, both are chiral. Okay, so there are a lot of different types of the molecule. Okay, so show the chirality. Okay, and one most common the molecule is this molecule has the chirality center. Okay, so what's chirality center? Okay, so that's the tetrahedron kind of carbon with four different the substituent group. Okay, so sp3 hybridized the carbon kind of with four different attachment. Okay, so that's we call the chirality center. Okay, so sometimes kind of I just call them kind of the chiral center. Okay, or maybe just the stereo center. Okay, so chiral center actually belongs to stereo center. Okay. Yeah, stereo center definition we learned in chapter 6. Okay, so if you swap the two substitute group, okay, on the stereo center, okay, so changes conformation. Okay, and so here are some examples about the chirality center. Okay, so keep in mind sp3 hybridized carbon with four different attachments. Okay, the first one, okay, so this carbon has the OH hydrogen and then isopropyl group attached. Okay, so that's a different kind of four attachment as chiral center. Okay, and then this one also chiral center. Okay, OH hydrogen. Okay, and then last branch has the CC double bond, right branch just the CC single bond. Okay, that's different. Okay, and quite often the hydrogens is kind of ignored. Okay, so when we draw line angle structures. Okay, so you should a little bit keep in mind. Okay, there's hydrogen. Okay, so maybe attached to a chiral center. For example, this one. Okay, and then this carbon also has the four different the attachment. Okay, so should be the chiral center. Okay, and then one common. Okay, so if you have any question, okay, type in the chat window. Okay, so let me see what's the question. Most different attachment. Okay, most different. Okay, has to be different attachment. Okay, so if there are kind of the four same thing. Okay, so that's not be chiral center or any two same thing. Okay, all right, give you one example. Okay, so one common types question I showed in the future exam quiz is kind of give you one molecule, ask you identify all the chiral centers. Okay, this one. All right, okay. For example, this molecule, okay, so probably So first, okay, try to identify how many no necessary. Okay, so later I'll give more example. Okay, show other kind of atom can be chiral center. Okay, but so far you guys just focus on the carbon. Okay, carbon with four different attachments. Okay, right, carbon. Okay, with four different attachments. Okay, right. So try to find all the chiral center in this molecule. Okay, and so if you like here, you can turn the annotation function. Okay, and label the chiral center. Oh if you like here, you just kind of directly type in the chat window. Okay, so just tell kind of ask. Okay, so how many chiral center, okay, or chirality center in this molecule? Okay, All right, take a try. Okay. All right, keep in mind the chiral center. Okay, Chirality Center. So far we learned just kind of carbon. Okay, and that's sp3 hybridized carbon. Okay, so that means kind of the 4 different attachment on 1 carbon. Okay, and then yeah, that will be chiral carbon. Okay. All right. Okay, so. Okay, so that's wrong. Okay, sp3 hybridized. Okay, not sp2. Okay, so sp2, yeah, you cannot have 4 different attachment. Okay, all right, try it. Okay, yeah, this morning. Okay, so yeah, now the student gave the right answer. Okay, so let's try it again. Okay, this afternoon. Okay. All right, so that's the right one. Okay. Okay, that's the second right one. Okay, third one. Okay, good. All right. Okay. Okay. So someone already provided the right answer in the chat window. Okay, should be totally full. Okay. So again, keep in mind. Okay, so yeah, has to be sp3 hybridized carbon. Okay, tetrahedron carbon. Okay, so that's shown here. Okay, tetrahedron carbon. Okay, so if for sp2 sp carbon. Okay, so that's you cannot have a full attachment. Okay, because there's a CC bond or CC triple bond in the molecule. Okay, so or CO bond. Okay, right. All right, so pretty close. Okay, only make one mistake. Okay, so this carbon is just the sp2 hybridized. Okay, so CO bond. Okay, so that's want to be okay. All right, so can anyone identify the last one? Okay, where's the last chiral center? Okay, chiral carbon and mark it. Okay, the yellow one. Yeah, is right. Okay, here. Okay, pretty good. Okay. All right, so yeah, you guys did a better job than this morning. Okay, okay, clear out. Okay. All right. Okay. So yeah, 4 different attachment. Okay, and has to be tetrahedron carbon. Okay. So that's this guy here. 2, 3, and 4. Okay. So this 4. Okay. And so has to be tetrahedron carbon. Okay. So yeah, yeah. So yeah, 4 different attachment. Okay. So yeah. This carbon, okay, so that's your CO bond. This also CO bond, okay, that's sp2 hybridized, okay. All the carbon on benzene, okay, so sp2 hybridized, okay. sp2 hybridized, okay, so yeah, that's carbon, okay, so yeah, the something like this, okay. So you cannot have 4 different attachments, okay. So this already have 2 signals here, okay. All right. Okay, good, okay. So yeah. Make sure you know how to pick up the chiral carbon, okay, and then I do one more molecule, okay, so you can practice when you go home, okay. And so this was actually from the last year exam or quiz, okay, so I couldn't remember, okay. Yeah, there's CC bond here. There's an ester, okay, so yeah, cyclic ester. Okay, so yeah, recall this molecule, okay. Yeah, so yeah, that's right, okay, so yeah, those 4 carbon all are chiral centers, okay. Also, we call kind of Chirality Center or Chiral Center, okay, same thing, okay. Yeah, for this molecule case, yeah, you can practice when you go home, okay, and then I will provide the answer in the class next time, okay. Yeah. Okay, and so just the one thing keep in mind, okay, so yeah, okay, so maybe write it down here, okay. So for one molecule, okay, so if there's only one chiral center, okay, so this molecule must be one molecule, okay, so must be chiral, okay. It's chiral. So one molecule with one chiral center, okay, only one, okay, keep in mind only one. And this molecule must be chiral, okay, so one, that's yeah, for sure, okay, no problem, okay. So yeah, we don't have these three here, okay. So yeah, if they have kind of yeah, only one chiral center, okay, so those yeah molecule, yeah, it won't superimposable with the mirror image. This molecule will be chiral, okay. But yeah, if one molecule has more than one chiral center, okay, it's not necessarily this molecule will be chiral, okay. Okay, so give you guys one example, okay. All right, for example, this molecule, okay, all right, this one, okay, so yeah, relatively easy, okay, can anyone label the yeah, two chiral center for yeah this molecule, okay, for me, okay, just yeah, okay, that's right, okay, pretty good, yeah, that's here the two chiral centers, okay, yeah, so these two, okay, all right, and then yeah, if we yeah this molecule has two chiral centers, okay, and if we yeah draw its mirror imaging, okay, so that should like this. Right, and then you'll find, okay, so yeah, these two molecules actually same thing, okay, so we can take one molecule and superimposable yeah to another one, okay, so that means yeah these two molecules kind of yeah this molecule kind of yeah not chiral, okay, chiral definition kind of yeah non-superimposable to its mirror imaging, okay, so this one superimposable to its mirror imaging, okay, so that means yeah you cannot just yeah use the yeah how many chiral centers or kind of there's chiral centers or no chiral centers to determine one molecule is kind of chiral or not, okay. And we'll have some other way to yeah determine kind of yeah one molecule chiral or achiral, okay. So we'll learn it later, okay. So yeah, on the other hand, okay, so yeah, if we have one object kind of yeah mirror imaging superimposable, okay, so yeah, then we'll kind of identical that's chiral, okay, so achiral, okay, so that's yeah this molecule kind of achiral, okay. So another example is yeah 2-propanol, okay, 2-propanol, okay, so yeah, structure showed here, okay, so we clearly see yeah there's yeah no yeah. This is the mirrored, okay. First mirrored, okay. First has mirror, okay. A second, okay. So yeah, it's superimposable with its mirror imaging. That should be achiral, okay. Yeah. Okay. So I'll give you guys a more yeah example, okay. Right. So yeah. So now yeah, another definition kind of achiral, okay. So yeah, 2-propanol, okay. 2-propanol, okay. So yeah, you can see there's yeah no chiral centers, okay. No chiral center, okay. And then yeah, if you do mirror imaging, okay, so that's it's mirror imaging, okay, and then you find kind of yeah this mirror image actually kind of same molecule. You just kind of yeah rotate yeah yeah like maybe 180 degrees, okay, 120 degrees, okay, so exactly kind of yeah match each other's, okay. So yeah, again, so if you yeah two yeah molecule, okay, mirror imaging to each other, okay, but yeah they superimposable to each other, that's what we call kind of identical. So then this molecule will call kind of achiral, okay. Yeah, same molecule, just different views, okay. Right, okay, so now yeah, answer some of your questions, okay. So yeah, how do we determine one molecule kind of chiral, achiral, okay? So there are a couple of ways to do it, okay. And the easiest way for you guys to learn is kind of yeah, try to find is there any kind of symmetry plan cut through this molecule, okay, and make half is kind of mirror imaging to another half, okay. So if you can find this symmetry plan, okay, this molecule will be achiral, okay. If you how do you rotate the molecule, how do you kind of circulate, okay, and then how to flip the molecule, but you cannot find such a symmetry plan, okay. This molecule will be the chiral molecule. This molecule will be chiral, okay. Okay, so example showed here, okay. So this is the 2-chloropropane, okay, 2-chloropropane, okay. And so yeah, easily find one safety plan, okay. So that's cut through kind of hydrogen, carbon, chlorine, okay. And then yeah, cut it to half, okay. So one half that's methyl is mirror imaging to another half that's methyl, okay. So in this case, yeah, we can find one safety plan, okay. And then this molecule will be achiral, okay. And then opposite example is the 2-chloroputene, okay. Butene, there's one more carbon, okay. So if we do the same thing, okay, hydrogen, carbon, chlorine, and then try to find this one as a symmetry plane, okay. and you find kind of one half is methyl, another half is the ethyl. Okay, so methyl, ethyl not mirror image into each other. Okay, and if you try other ways, okay, so you still cannot find the symmetry plan. Okay, so that means here there's no symmetry plan for 2-chlorobutene. Okay, and then 2-chlorobutene is a chiral molecule. Okay, and overall, okay, so if for one molecule, you can find one symmetry plan. Okay, cause this molecule half is mirror image to another half. Okay, this molecule will be a chiral. Okay, if you cannot find such a plane, okay, so this molecule will become kind of a chiral. Okay, all right. Okay, so give you another example. Okay, and then you understand what I'm talking. Okay. Yeah, for example, these two molecules, okay, and so both kind of the diol, okay, 2 OH group, okay. All right, and then for the first one, okay, so we are easy to find the kind of the symmetry plan, okay. Just cut through the middle of these two CC single bond, okay. So middle of this bond. All right, and then you can find the top half is mirror image to the bottom half, okay. So that's this molecule will be the A chiral, okay, A chiral. But if we do the same thing, okay, so for the second molecule, okay, so cut in the middle of this molecule, okay, and then this symmetry plan won't be the symmetrical the plan, okay, because the one OH kind of going up, one OH going down, okay, so that's not mirror imaging to each other, okay, and that's won't be kind of the symmetry plan, okay. And so then you can try some other ways. Okay, you can draw the symmetry plan here or symmetry plan here, whatever you will do. Okay, so cannot make half kind of mirror image to another half. Okay, so that means this molecule has no symmetric plan, and this molecule will be chiral. Okay, and for this example, we can clearly see. Okay, so for both molecules, okay, have the two chiral centers. Okay, but here the one is chiral, one is achiral. Okay, so that means for multiple kind of the chiral centers, okay, so that you cannot use that kind of the way to determine chiral or achiral, okay. So if there's only one the chiral center, that's definitely gonna be chiral molecule, okay. But here if there's 2 or 3 or 4, okay, that's hard to say, okay. So you have to use try to find symmetry plan, okay. All right, okay. So next, you guys take a try, okay. So I will draw 4 molecules, okay, and you guys determine which is chiral, which is achiral, okay. And then last one. All right, okay. So let's do this, okay. I just label A, B, C, D, okay, B, C, D, okay, and then just type here the answer in the chat window, okay. So A is chiral, B is chiral or achiral, kind of B is chiral, A chiral, C is chiral, achiral, kind of D is chiral, achiral, okay. So type in chat window, okay. Right, take a try, okay. So keep in mind, okay, so you try to find is any symmetry plan cut through this molecule, okay, make half is kind of mirror image into another half, okay. If you cannot find such a plane, okay, so this molecule will be chiral, okay. If you can find this such plane, okay, so then this molecule will be achiral, okay, right. So while you're working on this question, okay, so just here a couple of things, just here the quiz, okay, so quiz 4, okay. Something kind of send an email. Okay, so quiz 4 will cover just mainly chapter 6. Okay, and but there are some include some kind of old knowledge, okay, like naming, okay, because we have to kind of assign easy for some kind of molecule. So make sure you know how to do that. Okay, don't forget kind of the knowledge learning chapter 5 and also chapter 12. Okay, and so I have actual office hour from 2 to 3 today. Okay, so yeah, if you need some help, please come to my office hour. Okay. That's a good question. Okay, exam 2. Okay, so yeah, very likely. Okay, so yeah, I will be still the give exam 2 on smart work. Okay, smart work. Okay, so do online. Okay, yeah, because the exam 2 mainly about the chapter 7. Okay, so yeah, so chapter 7 is no problem. You can do it online. Okay. Yeah, make sure that get you some pen, eraser, and those the cell phone or maybe digital camera ready. Okay, when you take quiz 3. Okay, so quiz 4. Okay, and so yeah, let's be in the Wednesday class. Okay. Yeah, so this exam, I mean the quiz 3, you guys should be able to finish in 20 minutes. Okay, I will give you 30 minutes. Okay, so yeah, extra time for you to scan your exam and also hand it online. Okay, scan your kind of quiz. Okay, hand it online. Okay. Okay, so not anti. Okay, so I just ask kind of the A Chiral, I guess. Okay. Right, similar amount of question as the previous quiz. Okay, 11 or maybe 12 questions. Okay. All right. Okay. So let's do it one by one. Okay. Right. Can anyone tell me? Okay. So okay. All right. So let's do it one by one. Okay. All right. First one should be A Chiral. Okay. I just use A. Okay. Reason for that kind of there's one simply plan. Okay, so cut through this molecule through this carbon, this hydrogen, and this OH group. Okay, so pretty much let's get one. So remember, so this hydrogen kind of point towards you. Okay, and then OH group go inside. Okay, so then let's can do this way. Okay. Cut through this molecule like this way. Okay, yeah. And then this two carbon will mirror image to another carbon K2. Okay, so that's the A Chiral. Okay, so that's you can find symmetry plan. Okay, but for the B. Okay, so if you do the same thing. Okay, so cut through this 4 atom. Okay, and then on the left. Okay, so that's your double bond. On the right will be kind of single bond. Okay, won't be kind of the mirror image to each other. Okay, so that means this molecule B should be kind of Chiral. Okay, just use the C label Chiral. Okay, all right. And for C. Okay, C is kind of also very tricky one. Okay, and some people said kind of how about kind of we find one symmetry plan and just cut through this bromine, this carbon, this carbon, this bromine. Okay, so something like this. Okay, and but if you do that, okay, so the front of this plan, okay, only 1 carbon, but the back of this plan only 2 carbons. Okay, as you cannot do it. Okay, so I said, okay, so how about we cut through this molecule like this way. Okay, right, just kind of like this. Okay, right. So in this case, 1 bromine will going up, 1 bromine will going down. Okay, still the node kind of mirror image to each other. Okay. So for this molecule, no matter how do you do kind of kind of cut through. Okay, so won't be symmetry plan. Okay, this one should be the Chiral. Okay, right. For the last one, okay, last one is kind of the also tricky one. Okay, so last one actually kind of the A Chiral. Okay, because the use this pen. Okay. You can find one symmetry line kind of this carbon, this carbon, this carbon, and also this chlorine. Okay, so that's pretty much just like this. Okay, okay, and then this the carbon will mirror image to this carbon. Okay, so this molecule kind of the A Chiral. Okay, and don't worry about kind of 3 hydrogen on the carbon because 3 hydrogen kind of on carbon kind of quickly kind of rotate. Okay, so average out. Okay, so that's okay. Right, so yeah, now you guys know it's not easy for this chapter, okay? So yeah, you need to develop kind of three-dimensional view for certain questions, okay? Again, okay, so chiral molecule, okay, so you cannot find any simply plan custom molecule, half is kind of mirroring to another half, okay? On the other hand, okay, so will be a chiral molecule, okay? All right, okay, so now we talk about now a little bit about the chiral and the enantiomer, okay? Some students kind of confused, okay? So the chiral is refers to the property of one molecule, okay? So similar to the polar, non-polar, okay, we call kind of this molecule is chiral, this molecule is achiral, okay? This molecule has higher boiling point, this molecule has lower boiling point, okay? Refer to one property, okay? And for chirality, okay, actually enantiomer, okay, actually enantiomer refers to the relationship, okay, between two molecules, okay. So enantiomers always come in pairs, okay. So we see these two molecules are enantiomers, okay, or these two molecules are not enantiomers to each other, okay. So that's just relationship between two molecules, okay. But it will be safe to say, okay, so if one molecule is chiral, okay, it will have an enantiomers, okay. Okay, enantiomer non-superimposable mirror image. Okay, and if one molecule is achiral, it won't have enantiomers. Okay, so that will be safe. Okay. All right. Okay. And so one important kind of when you draw a chiral molecule. Okay, so little bit careful. Okay, don't kind of swap one molecule. Okay, so you can rotate the swap and these two substitute. Okay, because you will change the chiral configurations, okay, and also change its assignment, okay. So when you draw a chiral molecule, okay, you can rotate, okay, and then flip it, no problem, okay. For example, this molecule, okay, so that's two butanol, okay, and then you can rotate like maybe 120 or 130 degrees, okay. So that's you're generally something like this. Okay, so those two are same molecule, and then most time you actually cannot even you can ignore the hydrogens, okay, when you draw line on the structure, okay. So that will become like this. Okay, so that's also same thing, okay. And even you can flip this molecule, okay. All right, so flip is kind of hard, okay. So but make sure you still draw the right way, okay. And when you flip the case, so the OH will go kind of inside of the paper, okay. And then ethyl will go left, okay, and methyl will go right, okay. So all those are same, okay. And the last kind of some important topic about the refraction and those the substitute group kind of change, okay. So when you do one refraction, okay, so that actually generates the mirror images, okay, also kind of I mean for the chiral molecule, okay, probably it's kind of enantiomers, okay. And actually it's equals to you swap of two substitute, okay. And here's one example, okay. So this is the original molecule, okay. And if you do one reflect, okay, and then that's generally kind of the mirror imaging, and then that's enantiomers, okay, because the original molecule has four different attachments, okay. So that's be kind of the chiral molecule, okay. And then that's the pair of enantiomers, okay. And if we swap of two substitute, okay, on one of these chiral carbons, okay, and you also generate the original kind of enantiomers, okay. So these two enantiomers, okay, actually kind of same molecule, okay. So that's the means the one refraction equals to one exchange of the two substitute, okay. And if you do two refraction, okay, so or two exchange of the substitute, okay, actually the switch is back to original molecule, okay. So here's one example, okay. Right, so we have this chiral molecule, this is the Chiral Centerscape. So if we swap OH and also Br, okay, actually we generate kind of it's mirror imaging, okay. So also it's the enantiomers, okay. And then we swap again, okay. So this time, okay, so instead of the OH Br, okay, we swap kind of the Br and also methyl group, okay. And then we generate actually its original molecule, okay. These two, okay, actually kind of same molecule, okay. In other words, okay, so the enantiomers of enantiomer, okay, so that's actually kind of original same molecule, okay. And so you can extend this the trend the further. Okay, so if you do even number of the refraction of the swap of the substance group, okay, then you generate original molecule. Okay, so even number. Okay, but if you do odd number of the refraction over exchange, okay, you generate enantiomers. Okay. Make sure you remember this information, okay, because you later use this information, okay, so to learn some kind of the RS assignment, okay. Right, here's the RS assignment, okay. Right, so for the two enantiomers, okay, so they are mirror imaging, but they are not same compound, okay, so non-superimposable, okay. So if they are two different compounds, okay, we have to give their kind of different names, okay, and then to identify these two molecules, okay. And the people develop we call the RS the systems, okay, to distinguish two enantiomers, okay. Similarly, like we learn the EZ for cis choice isomer or arcane, okay. All right, okay, so that's the two the enantiomer both called tochlorobutene. We have to give their kind of special names to distinguish these two enantiomers, okay. Right, okay, so now we'll learn how to okay, maybe get another page. How to assign RIC for the chiral centers, okay? So not hard, okay, do the following step, okay? So I use this one as example, okay? So that's BR, okay? Hydrogen point away from you, and chloride, and then here, C3, okay. All right, okay, so definitely this is the chiral center, 4 different attachment, okay. The whole molecule is chiral, okay. Okay, and then what you need to do the first step is assign the priority of the 4 different attachment, okay. This priority kind of the assignment is same as the easy priority assignment, okay. So the goes to atomic number, okay. Higher atomic number, higher priority, okay. So BR definitely has highest priority, okay, because highest kind of atomic number, okay. And followed by CR, okay, and then followed by this methyl. Methyl has kind of carbon, okay. That's 2, okay. This one should be 3, and hydrogen has the lowest priority, okay. So here's actually kind of pretty easy, okay. Just remember, okay. So RS priority assignment, okay. So the same as easy priority assignment, okay. So that's based on atomic number, okay. So this priority rule also called Kahn ingot preload kind of sequence rule, okay. Right, and then the second step, okay. Try to visualize this molecule, okay. Put the lowest priority group, okay, away from you, okay. So point away from you, okay. And then falling, okay. So draw the arc, okay, from the highest one, okay. So number 1 to number 2, okay. And then from number 2 to number 3, okay. Try to draw this kind of arc, okay. So 1 to 2, 2 to 3, okay. And so if this arc direction is kind of clockwise, okay. So like this example, okay, clockwise, okay. And then we assign it as R, okay. So if this the arc directions goes counterclockwise, okay, and then we assign this the chiral centers S, okay. So that's pretty easy, okay. Right. So we do other example, okay. For example, this is the 2-butyl, okay. So for 2-butyl, okay, so also there's chiral center here, okay, and then 4 different attachments, okay, and easy to assign kind of the priority, okay. So OH group has highest priority because oxygen has higher atomic number, and then hydrogen has the lowest priority, okay. Difficulty comes kind of these 2 parts, okay. Step 2, okay. Step 2, okay. So just make sure that the low priority group is point away from you, okay. And then other 3 substance group, okay. So you draw an arc from the highest one to the lowest one, okay. So 1 to 2, 2 to 3, okay. To look at the direction of this arc, okay. So this direction arc of if it's kind of shows clockwise, okay. Clockwise, okay, like this one. Right, and then that will be R, okay. So if this arc direction goes kind of counterclockwise, okay, then you need to, this will be designed as the other S, okay. So that's only 2, okay, 2 possibilities, R or S, okay. All right, okay, and then for the yeah, two butanol, only one problem is first they are same, okay, so both kind of carbon, okay, for this the ethyl methyl, okay, and that's fine, okay, so we do the same thing as easy assignment, okay, so move to next layer, okay. So for the methyl, you have only 3 hydrogen attached, okay. For the ethyl, you have kind of 1 carbon, 2 hydrogen. So ethyl definitely has higher priority than the methyl, okay. And then the hydrogen already point away from you, okay. So you just draw the arc from 1 to 2 and then 2 to 3, okay. So that's here we just use Newman projection. That's easier to see it, okay. 1 to 2 and 2 to 3, okay. So that's here goes to kind of clockwise. That means this molecule is also R, okay. And the full name called R2 butanol, okay. So that's here similar to easy assignment, okay. So put the stereochemistry assignment into the parenthesis and link it with the hyphen to the full name, okay. Right, some other example, okay. So this molecule, okay, so the highest priority should be kind of chlorine, and then followed by kind of OH, and then followed by hydrogen, this methyl group, okay. Hydrogen already point away from you, okay. So then you can go ahead and draw the arc, okay. So so now this kind of arc goes to kind of counterclockwise, okay. So go through this direction, okay. So that means this one should be S, okay. So it's not necessarily kind of hydrogen is always the lowest priority, okay. So you can have other group, okay, other atom as kind of low priority, lowest priority groups, okay. For example, this molecule, okay, the highest one definitely kind of bromine, and then followed by kind of this methyl, okay, methoxy, okay, and then followed by kind of this ethyl group, okay. And the methyl group definitely kind of the lowest priority, okay. So methyl, okay. So not necessarily kind of hydrogen, okay. And then lowest priority group already point away from you, okay. So that's here we can go ahead and draw the arc from 1 to 2 and then 2 to 3, okay. 1 to 2, 2 to 3, okay. So that's here looks like clockwise. That means it should be S, okay. Right. Okay. So normally speaking, kind of I won't give you so easy example in the quiz exam, okay. So quite often happen kind of the lowest priority group, okay. So point towards you, okay. And then how do you assign RS, okay? Example showed here, okay. So this one, also work 1 carbon, okay. So 4 different attachments, okay. So so hydrogens kind of lowest priority group, okay, point towards you, okay. So in this case here, when you assign RS, okay, so you can do the 43 ways, okay. So first just redraw it, okay. So you rotate kind of center CR bond, okay. So like 120 degrees, okay, clockwise, okay. So hydrogen will move to the bromine position, bromine will move to the OH position, OH will move to here, okay. So in this case here, we can move the hydrogen away from you, okay, and then we can easily kind of then RS, okay. So 1, 2, 3, and then that should be kind of the counterclockwise, okay. Nice, okay. So that's the relative hard way to do it, okay. So you have to redraw the molecule, okay. And the second way, okay, to do it, okay. So we still use this molecule as example, okay. Second way to do is kind of we just learned in the maybe 2 or 3 slides before, okay. So you can swap the 2 starting group, okay, and then you redraw it, okay. So you can generate kind of it's enantiomers, okay. But enantiomer, keep in mind, okay, so has the opposite assignment here, for the Chiral Center, okay. So you have give invert name, okay. So swap hydrogen with starting group, okay, point back, okay, and then invert name, okay. For example, this molecule, okay, so we do the same thing, okay. So we can swap here the bromine and also the hydrogen, okay. So that's we can point and make it the hydrogen going back, and then bromine go front, and then OH goes here. Okay. All right. So that's please keep in mind, okay. So if we swap once, okay, so that's actually general kind of it's mirror imaging, okay. So mirror imaging, okay. So if we design RIS, okay, so highest 1, 1, 2, 3, okay, 1, 2, 2, 2, 2, 3, okay. So that's looks like the clockwise, okay, but the because this is it's mirror imaging, okay. So for the real assignment for the original molecule should be S, okay. So that's here why you kind of invert naming, okay. So two enantiomer, okay. So one is R, another has to be S, okay. So that's here you need kind of here give name, okay. Opposite, okay. And then that's here still not easy, okay, because you have to kind of redraw the molecule, okay. So the easiest way to do it kind of here just here go ahead and kind of here then RS, okay. So we still use this molecule as example, okay. Go ahead then RS, okay. So yeah, 1, 2, and then 3, okay. So yeah, hydrogen pointer towards you now still, okay. So if we go ahead then RS, okay. So looks like kind of clockwise should be R, okay. But because hydrogen point towards you, okay, so you need invert naming, okay, invert naming, keep in mind, okay, and then R, okay, so yeah, should be give S, okay. Yeah, that's same kind of conclusion we tried the previous two method, okay. So I encourage you guys kind of use the third method, okay. So if you lowest party group, okay, point towards you, okay, go ahead then RS, okay, but if it's clockwise, okay, so you need to give the S, okay, if counterclockwise, okay, give the R, okay, so that's just invert naming, okay, so that's what's happening, okay. Right, and then a little bit more detailed information about the assigned party. Okay, so let's see. We learned probably a little bit talk about a little bit either the chapter 5. Okay, the chapter 6. Okay, so if you're the first layer same, okay, and then you move to second layer, okay, and then second layer same, you move to the third layer, okay, and here you kind of more detailed examples, okay. And then, for example, we try to compare the priority of these two branches, okay, priority of these two branches, okay. And then, the first layer same, okay, so both are carbon, okay, and then we cannot distinguish which one's higher, okay. So a priority based on kind of atomic number, please keep in mind, okay. And then we move to next layer, okay. Next layer, okay, so each has kind of the oxygen, nitrogen, hydrogen, oxygen, carbon, hydrogen, okay. And then how to examine kind of priority, okay. So examine from highest priority atom to lowest one, okay. The highest one, oxygen, same, okay. And then we move to the next one, okay. And then top one has a nitrogen attached, bottom one has the carbon attached, okay. So now we can stop here, okay. We already tried difference, okay. Definitely kind of feel the top one has higher priority, okay, because nitrogen has kind of higher atomic number, okay. And then the top one be higher priority than the bottom one, okay. So once we determine kind of the which one has higher priority, okay, and we can stop here, okay. Don't need to move further, okay. So for example, here these two, okay, so we can distinguish the priority based on the second layer, okay. Don't need to move to third layer, okay. So for example, the bottom one, the third layer has fluorine attached, okay, and then for the top one, third layer only hydrogen attached, but I don't care, okay, because the second layer already told me kind of the top one has higher priority, okay. So and then there's one extreme situation, okay. So the second layer are also same, okay. And then how do you proceed, okay? So example showed here, okay. So we try to compare the priority for these two second group, okay. The first layer both are carbon, okay, and second layer, okay. So carbon, nitrogen, hydrogen, and then bottom one also carbon, nitrogen, hydrogen, okay, also same, okay. And then that's carbon, nitrogen, carbon, hydrogen, okay. Then how do we can move to the third layer, okay? So you examine the atom bound to the highest priority kind of on the second layer, okay, second shell, okay. And the highest one, okay, so carbon, nitrogen, hydrogen, okay, highest one should be nitrogen, okay. Nitrogen, okay, so we need to examine what's the attachment on the nitrogen, okay. For the top one, hydrogen, fluorine, okay. For the bottom one, hydrogen, chlorine, okay. Chlorine has higher priority than fluorine, okay. So that means the bottom one win, okay. Bottom one is kind of the higher priority, okay. And so we can stop here, okay. So don't need to move further on, okay. Even for the top one has a chlorine attached to on the carbon, okay, on the second layer carbon, okay, and then bottom one only fluorine attached, okay. But we don't care, okay, because the attachment on nitrogen already tell difference, okay. So that's how do you kind of move one layer to another layer, okay, and eventually tell kind of difference, okay. Atomic number, okay, so RS and also EZ, okay, all based on atomic number, okay. Not different from your functional group, priority. Functional group priority kind of the OH higher priority than kind of chlorine, bromine, whatever, okay. So that's already showed you guys here. priority based on atomic number, okay? Same as kind of easy, okay? So go ahead. Little bit too far away. All right. Okay, so now it's you guys your turn, okay? Take a try, okay? Try to assign the RISF for all the chiral centers, okay? For the H4 molecule, okay? So the chiral center here, chiral center here, chiral center here, and also last one kind of your most challenging one, okay? So this one is the Newman projection, okay? So if you don't know how to do the last one, you can wait a little bit, okay? I will give you guys kind of explanation, okay? So don't worry, okay? But yeah, you can try ABC, okay? And if someone like, you can directly use annotation labeled AR or IC for the A and B and C, okay? Yeah, take try, okay? Yeah. Yeah, any student can try it, okay? We don't need one answer, okay? So yeah. All right, okay. Let's see, okay. Pretty good, okay? So yeah, some students already put right answer for the yeah, ABC, okay? All right. For A should be S, okay? Because their chlorine has highest priority, okay? And then followed by ethyl and followed by the methyl, okay? So you draw kind of your arc like the counterclockwise, okay? Should be S, okay? And B, a little bit challenging, okay? So yeah, maybe you still draw it here, okay? So yeah, this morning the yeah, South student can use wrong assignment for the B, okay? OH or doesn't matter, okay? So highest one should be the yeah, OH or okay? So yeah, lowest one should be here, okay? And then comes kind of question, okay? So yeah, the top branch or bottom branch, which one has higher priority, okay? So right, top one or bottom one, okay? So yeah, for the top one, okay, so this carbon, okay, only attached with yeah, 2 hydrogen and then 1 carbon, okay, 2 hydrogen, 1 carbon. For bottom one, okay, CC double we treat as kind of yeah, attached with yeah, 2 carbons, okay. So definitely kind of bottom one has high priority because there's kind of 1 carbon, okay. So that's yeah, 2 and 3, okay. And then you draw the arc 1, 2, 2, and then 2, 2, 3, okay. So that's yeah, should be clockwise. R is the right answer, okay. And then for C, okay, so yeah, C, the tricky thing is kind of your hydrogen kind of actually point towards you, okay? The hydrogen kind of ignored, okay? And then yeah, when you line a particle, keep in mind still yeah, based on atomic number, okay, not based on functional group one, yeah, number, okay. So yeah, the highest one should be amine, okay, so N, okay, and then followed by this carbon because of the acid kind of yeah, you treat as yeah, attached with yeah, 3 oxygen, okay, and then in that case this one, okay, so yeah, if you draw RK, so yeah, looks like yeah, counterclockwise, okay. So amine to acid and then to this isopropyl, okay, looks like clockwise, counterclockwise, okay. But because the hydrogen point towards you, okay, that should be R, okay, that should be R, okay. All right, so now we move to the yeah, most difficult one, okay. So this here the yeah, we call it kind of yeah, Newman projection, okay. So in the yeah, previous class of chapter 6, we learned how to convert yeah, wedge depth structure into a Newman projection, okay. But when you design RS, okay, so the yeah, for your beginner, okay, better kind of convert the Newman projection to back to wedge depth structure, okay, and then you can design RS, okay. So how do we do that? Okay, so first you have to identify which carbon is chiral, okay. So not front carbon, okay, because front carbon has 2 hydrogen attached to it, okay. So that's won't be chiral carbon. Chiral carbon has 4 different attachments, okay. So the real chiral carbon is the back carbon, this guy, okay, this big circle, okay. Because big circle has the 4 different attachments, okay. And then next kind of how do you convert to the wedge depth structure, okay. So yeah, for the back carbon, you can see kind of hydrogens here, okay. So you want the joint kind of hydrogen point away from you, okay. So what you can do is kind of put your ion like this way, okay. look see this molecule like this. Okay, so yeah. Right, and then afterwards, okay, so yeah, if you look at this way, okay, so definitely kind of chlorine on the top, okay, right, and then yeah, this methyl group, okay, methyl group will point towards you, okay, so that's methyl group will point towards you, okay, and then this is the acyl group, okay, so there's acyl group with the front carbon with kind of the C3, okay, so in the kind of plane, okay, in the plane same as kind of Cr, okay, so that's we draw like this way, okay, CH2, okay, that goes to your right, okay, so that's we draw on the right, okay, so goes to right, okay. And in the end, okay, so hydrogen kind of the point away from you, okay, you just connect with the dash line, okay. Okay, so that's how do you convert the Newman projection to the wedge dash structure, okay, and then for the easy to design RIs, okay, so highest one, 2, 3, okay, so acyl group has higher priority than methyl, okay, and then you draw the arc, okay, from 1 to 2, 2 to 3, okay, and then that looks like R, okay, so clockwise, okay. So far, you better do this way, convert Newman projection to that structure, okay. But later, once you get kind of the more knowledge about a little bit of three-dimensional view, okay. So I will show you how to kind of directly design RS using a Newman projection, okay. Okay, so I guess that's it for today's class, okay. So yeah, and stop the recording.